Welcome back, my awesome math scholars. Today we're going to be studying the coordinate plane, relations, and functions. This is primarily a vocabulary lesson, and it's mostly review. The relations and functions are new, but the coordinate plane should be review from last year. If you look at the graphic I put up here, remember a coordinate plane is basically a grid where you got two axes, an x and a y, and there's a big C here because that's where we start up here in the first quadrant on your upper right. And we're going to go around counterclockwise to the left until we get to the fourth quadrant and we stop. That's what that is looking at. So look at that. Make sure you understand it. We're going to go back over it, but just to be clear. Okay. So this is new. We have a new SOL that we're working on. We're working on 712, and your job is to represent relationships with tables, graphs, rules, and words. When they say relationships, they mean functional relationships between ordered pairs and solutions, solving equations, that kind of thing. And we're going to go over how we do that moving on. Okay, so first of all, I know I gave you your notes, and on the very top it's got a foldable. We're going to skip that for a second, and we'll go over and label that when we get into class. But for now, I want you guys to go through the vocabulary with me, so when we come into class, we're able to do that foldable very easily. Okay, so a coordinate plane or coordinate system is formed by the intersection of two number lines at a point that meet at their 0 points. So it looks like this. We've got one line that's vertical that goes this way and one line that's horizontal, and they cross at that single 0 point in the middle. An ordered pair is a pair of numbers, and we label it X and Y, that's used to plot or put points on the coordinate plane. So if we're plotting them, that means it's kind of like Battleship. It's where we're saying, okay, we're going to go over here and then we're going to go up here or down here. It's telling it, it's our GPS, kind of like the GPS in your car. It tells you where to go. The X coordinate is the first number in the ordered pair. It is also called the domain. Another thing that you can think of it as is your independent variable. If you're in science, remember that's the thing that you're changing. So that is the thing that you're controlling. The independent variable is what I'm changing in my science experiment. And it corresponds to the number on the x-axis. So when you're graphing in science and you think about this, normally your graphs look like this. Well, this is the x and this is the y. So this is your x-axis. That's the first area that you're going to move along when you're plotting points. You have to look at the x value first. And that's what we're saying here. That's your domain. The y coordinate is the second number in the ordered pair. It is also called the range. And if you forget between the domain and range, which one's which, think alphabetical. D comes before R, X comes before Y. So that helps. Domain is with X, range is with Y. Just a quick and easy way to remember it. Okay. But Y coordinate is the second number in the ordered pair, also called the range. It corresponds to the number on the Y axis. And the y-axis is the axis that goes up and down. And if you're thinking in terms of science experiment, this is also known as the dependent variable. So that's what's changing as a result of what I change. So if I change how much food my dog gets, then the dependent is how much weight he gains or loses. So that is, or how many pounds he weighs. The origin is the point at which the x-axis and the y-axis intersect or cross. And it is represented by the order pair 0, 0. Because if you remember when I talked about it at the beginning, we said the coordinate system is actually formed by the intersection of two lines, number lines, where they meet at their 0 point. That's why it's 0, 0, because 0 on the x and 0 on the y. So it's 0, 0. The quadrants are the 4 sections, or if you want to call them regions, that are formed when the two perpendicular means they intersect at right angles. They're the two sections that are formed when these two lines intersect to divide the coordinate plane into sections. And they're labeled with Roman numerals. And those Roman numerals that we use are first, second, they look like eyes, third, and then 4 we write funny. It's IV, because V is 5, and we put 1 stick in front to take 1 away. You just have to memorize 1 stick, 2 sticks, 3 sticks, IV. The x-axis is the horizontal, which means it goes side to side number line on the coordinate plane, and the y-axis is the vertical, which means it goes up and down. So the x-axis is horizontal, y-axis is vertical. And that is the first page of your notes on page 19. And that should all be review. We will, like I said, we're going to do the foldable in class, so don't worry about the pink foldable for now. You can skip on to the back page of the coordinate system. Oh, no, let me go back. So this is an example of a coordinate plane. Not all coordinate planes are numbered for you. But if you can see, it intersects at 0. That's my origin. To the right, the numbers get bigger. So this is like the number line we've just been using for graphing inequalities. Think of the vertical number line, or the y-axis, as a thermometer. So 0 is in the middle. The higher you go, the numbers get bigger, and they're positive. If you think below 0, that's cold. So as we go deeper, more down, then the numbers get smaller. So, and if we look at this is quadrant 1. Remember I said it starts in the upper right, and we go counterclockwise, which is against the way a clock goes. So this is just quadrant 2. This is quadrant 3, and this is quadrant 4. And real quick, and we'll label this when we get to class, all of these points are positive and positive. These points, the x's are negative, but the y's are positive. On these, both are negative. And on these, all your x's are positive, but your y's are negative. So if you want to just think about that, or you can rewind the video and look at this again, but that's going to help us when we go to plot our points. All right. For coordinate system practice, this is on the back of your notes, page 20. We're going to practice plotting the points. And what I'm going to do is I'm going to use my highlighter, and I'm going to highlight the first number, because these are the ones that go on the x-axis. Remember, the first one's our domain, and it goes on the x-axis. The second number, oh, that's really dark. Let me see if there's another color we can use. Let's use blue so I can see it. Okay, the second number we'll call our y, or the range, and we're going to color those blue. This is just going to help us so we don't get confused when we go to label our points. All right, so our first one, we're going to move to, I always say we walk before we fly. So this is walking here, and this is flying here. Up and down is flying, walking we stay on the ground. So our first x says we're going to go 2 to the right because it's positive, and then we're going to go down 3 because it's negative. 1, 2, 3. So our point is right here. That is 2, negative 3. And if I think about that, that's in the fourth quadrant. You don't have to write that, but if you want just to have that for your notes later, you can. Okay. The second one says I'm at -8, so I'm going to move -8 on the yellow all the way over here. Then I'm going to go up 4. 1, 2, 3, 4. So this one is -8, 4. And if I look at where it's located in quadrant 2. Looking at number 3, I'm going to go over +3, which is this way. And then I'm going to go up 5. So I'm there. So my point is right here. That is a +3 and a +5, and I ended up in the first quadrant. So, and if we can keep going, we can keep doing this. If we do, I'll go ahead and do a couple more. If we do -7, goes all the way over here, and then I'm going to use blue. I'm going to go down to 1, 2. So my point for -7 and -2 is right here. And that is in the third quadrant. For number 5, it says I go 0 on the x-axis, which means I don't move. I'm right here. And then I'm going to go up 3. So this is 0, 3. Okay, so you can see how you do this. I want you guys to go ahead and try to do number 6, 7, 8, 9, and 10. Pause the video, try to label them and plot them yourself. Then restart the video and see if you got them right. So go ahead and pause the video now, label them yourself, and then restart the video. Okay, welcome back. I forgot to tell you when it's on an axis, then its location is not in a quadrant, and you just tell that it's on the x-axis or y-axis. So for number 6, we're going to go over 4, down 7. So this is number 6 right here. And it is in quadrant 4. For the next one, we're -5, -9, and that is in quadrant 3. For the next one, we're over 2, but we don't move, so we're right here, and that is at 2, 0. So we say we are on the x-axis. And then we have over 8, up 8. Sorry, that should have been more on the line. And that's in quadrant 1. And then our last one is -1, +4, which is in our second quadrant. So hopefully you were able to easily graph those. It should have been review. If not, there's some Edmodo practice, or not Edmodo, sorry, IXL practice that I'll post with the Edmodo lesson. Okay, now we're going to be moving into relations and functions and talking about what those mean. This is what it looks like when you have an equation with two variables, an x and a y. And this is what's called a linear equation because when we plot the points, it makes a straight line. So this one says identify all 5 coordinates where the line intersects perfectly. And I have to apologize because there's one that's not perfectly, so I have to apologize for that. But I'm going to look at this and say, okay, where is it perfectly intersecting on the grid? And if I look, I can see it perfectly intercepts right there. I'm going to start there and then kind of look up my line and see where else it's intersecting. It intersects right there, and then it intersects right here at that point, and it intersects right here. Now, I have to identify the x-coordinate and the y-coordinate for each of those points. I'm going to start at the farthest left, so that is right here at, and if I use my highlighter so you can see, I'm going -3, and then I went up 6. So my x-coordinate was -3, and my y-coordinate was how far I moved on the y, which was 6. So its ordered pair would be -3, 6. If you look at your next point, I didn't move anywhere on the x. I'm still at 0, but I did go up 2. So my y-coordinate was 2. Your ordered pair would be 0, 2. Then my next point, I went over 3 on the x. I went this way. And then I went down 2. So I went over 3 and down 2. So my ordered pair would be 3, -2. And then my last point, oh, I only did 4. Oh, that's fine, we'll do 4. My last point was all the way over here. Oops, I went too far. And then I went down 6. So it is 6 over 6 and down 6. So my ordered pair would be 6, -6. So the ordered pairs actually form a straight line, and we'll learn later that means that they form a function and what that all means. Okay, so if you turn to your next page on page 21, we're just going to go over page 21, do the notes, and then we'll come back and reiterate what we talked about on the notes. So a relation is just simply a fancy word for a set of ordered pairs. And remember, an ordered pair is just simply a set of parentheses with a y-coordinate and a x-coordinate, or x-coordinate and y-coordinate. So if we look at this example, this is a relation. You've got 1, 2, 3, 4 sets of ordered pairs. I don't know anything else about it. I just can call it a relation. It's kind of like having a family. Okay? You got your aunts and uncles, you got your mom and dad, you got your grandma and grandpa, and those are kind of like married couples stuck in parentheses. Relations can be written, and this is something you need to know, they can be written in different ways. They can be written as a function, which is an equation. They can also be written as a list, which is what we have right up above, or they can be listed as a table. It's kind of sloppy. And what I mean by table is what we just did on this previous screen, where we listed them right here. This is a table. So if we look at the example they gave us here, we have 4, 3, 5, 4, 0, 1, sorry, 0, -1, and 2, 1. So if we look at how we write it, we're going to list the x-coordinates on the left side and the y-coordinates on the right side. But you have to keep them on the same line if they're like a married couple. So we have 5 and 4, 0 and -1, and 2 and 1. That's all you have to know with regard to relations. The other thing that you had to know, and we also kind of already touched on this before, was that we can identify the first numbers and the second numbers based on, the one's an x-coordinate, but it's also called the domain. So those are simply the first numbers in the ordered pair, or the x values is the domain. Remember I said D comes before R, so that helps to remember. So if domain is the x values, we know range is the y values. and that is the second number in our ordered pair. What is the domain for the example that we gave above? So you're looking right here at all of the x values, and you're going to list them. Typically, we list them in order from least to greatest. So you could just list them as 4, 5, 0, and 2, but if you write them in least to greatest order, which is what they're going to do, they're going to write them as 0, 2, 4, and 5. If you're listing the domain or the range separately, you do not have to repeat numbers. So if I had 2 4s or 2 5s, I could just list them once and be done. And in the range example, I'm looking at the y values. So if we look at them in order, we'd start with -1, then 1, then 3, and then 4. And again, when you're listing the domain and range, they're just asking for the x and the y values. They're not asking for how they're paired up. Okay. If we graph a relation, it's just simply graphing ordered pairs. That's what we just have done for the last two examples. So if we look at the examples that we gave up above, we have 4, 3, which would be right here. We have 5, 4, which is right here. And we have 0, -1, which is right here. And we have 2, 1, which is right here. All right. If it's a function, typically it forms a straight line. Does it have to form a straight line? It does not, but typically it does. So a function, fancy, is a subset or a special section of relations. So it's a relation in which each element in the domain, which are your x values, are paired exactly with one element in the range, or the y values. So think of your closet. You got a set of clothes. That's your relation. But within that, you have a subset of maybe you have dressy clothes or you have casual clothes, but those are subsets. That's what a function would be. However, the function is very specific. It says that within my casual clothes, I have shirts that go with a specific pair of pants. And I can't have that shirt go with more than one pair of pants. So that's basically what a function is. It's a relation or a group of ordered pairs in which basically the x values don't repeat. So if you think about your closet, the relation is all of your closet, and your function is your school clothes, then that means your X's or your shirts, you can't have any shirt, one shirt match with more than one pair of pants. I know that's silly, but that's just an easy way for you to understand it. And there's several ways we can check and see if a relation is a function, and that's by simply looking at your X values or your domain. So I'm going to use yellow because that's what I've been using, and I'm going to look just at my X values. And I'm going to say, okay, looking at this first example, A, I have 3, I have 8, I have 5, and I have 1. So my domain would be 1, 3, 5, and 8. Do any of them repeat? No. I have 1, 3, 1, 8, 1, 5, 1, 1. So yes, that is a function because none of those values repeat. Now, if I look at B, this is a table, and let's look at my values. I have 7, 6, 7, 5, 1. Ooh, I heard 7 twice. So I'm looking at 7. One time the 7's paired with 8, the other time the 7's paired with 9. Not a function because your x repeats and it's paired with more than one y. So that's like saying I'm wearing my lucky number 7 shirt with my blue jeans and my black sweats. Can't do that. So no, this is not a function. So that's basically all you're looking for. It's very easy. One other really easy, if you're given a graph, instead of having to go and find all of the different points, you can do what's called a vertical line test. That means that when you're presented with a graph, this only works with a graph, you can determine whether a relation is a function by drawing a vertical line. Remember, vertical means up and down through each point on the line. If it does not pass through, more than one point, then it is a function. I love this one. This one's the easiest one. So think of taking a ruler. Let me go back up here to this example that we have up here. And I'm going to draw a big fat, let's do a big fat blue line. I'm going to do a big fat blue line. It's a straight line. Now, I'm going to take this and I'm going to drag it through and go over every point. Bloop. Oh, only touching one point right there at 0, -1. Here, oh, still only touching one point. Here I'm touching one point. Here I'm touching one point. So yes, the example up above is a function because it only touches one, this line only touches one dot each time. So if I had, I don't, but if I had another number right here, another point, and I took that vertical line and I passed, oops, I hit 2. I hit -1 and I hit -4 at the same time. That would not be a function, but that's not what we had. That was just an example of what it would look like. Okay, that is all we're going to do on our video today. We are going to come back in class and we'll talk about the back page of this set of notes, page 22, and we'll do our foldable in class. And then we're going to do some fun things with the coordinate grid and talking about relations and functions. Have a great weekend, and I will see you guys on Tuesday.